Okay, good morning class. So today we're looking at quadratic equations and inequalities. We're looking at exercise 2.8. And exercise 2.8 is on page 34. So quadratic equations is the heading for today. So we are told that the quadratic equation is one variable. Quadratic equations in one variable are equations that can be written in the form of ax squared plus bx plus c equals 0. We know that already. Not so much. That's not new to us. Where a is not equal to 0 because the highest power on x is 2. These equations will have two solutions. Okay? The solutions are also sometimes called roots of the equation. Sometimes roots, sometimes zero values as well. Zero values. They also give the zero values. Also the solutions to the equation. Okay, all the roots. The solution may not be rational. Sometimes it will be irrational, as you will see later on when we do completing of the square in equation form. It's possible to solve the equation by factorization, where the factors have integer coefficients. So that is what we dealt with thus far. Okay, two solutions may also sometimes be equal to each other, so you will have equal solutions. Okay, who knows when a quadratic equation will have equal solutions? So it's a perfect square trinomial. Not so. So if you got x squared minus 8x plus 16, if you factorize that, that will give you x minus 4 squared, and then x is equal to 4. That's what they're talking about here. The two roots are equal. Okay, that was x minus 4 times x minus 4. So we don't write x is equal to 4 and x is equal to 4 twice. Doesn't make sense. Okay, that's when they're talking about two solutions can be equal to each other. Okay, but later on we'll talk about whether roots are irrational and whether the solution does meet the squares. Okay. Solving quadratic equation by factorization. So let's go with this here quickly. This is example 1 on page. Example 1 is on page 32. Okay. So it says solve the quadratic equation. You got x squared minus 5x plus 6 equal to 0. So how are we going to factorize this? We're going to use the trinomial factorization there. Not so. So what we need a product line here. So what factors go on the side of the barrier? 1 and 1. On the other side, 1 and 6, 2 and 3. You add or subtract our products. We add it. Why? Because the last term is positive. Okay, the board is jumping around here. I'm going to pause the video and try and sort that out quickly. Alright, so let's hope this did the trick. So, let's go. So the factors needs to give us, if we said we're going to add it, it must give an answer of 5. So 1 times 6 is 6, 1 times 1 is 1, you add to get 7. We're looking for 5. 1 times 3 is 3, 1 times 2 is 2. 3 plus 2 is 5, and that's what we want. There's a 1 and a 2, a 1 and a 3. Now I know some of you have your own way of doing this. It's fine, you can use it. Okay. So it's a 1 and a 2, a 1 and a 3. That's x squared. So that's a x and a x. What about our signs? Both must be the same sign. Because this is negative, in this case both is going to be minus. So take the sign of the middle term. In grade 10 we've done this already. So we say that x minus 2 is equal to 0 or x minus 3 is equal to 0. Not so. So x is equal to 2 or x equal to 3. And we can check if we are right. If we put 2 into the original sum, it's going to be 2 squared minus 5 times 2 plus 6. 2 squared is 4 minus 10 is minus 6 plus 6 is 0, and you can done the same for 3. People, any confusion there? No, sir. Alright, let's carry on with our lives as if nothing happened. Right, example 2, and this is on page 32. 33. Also, these are the examples for exercise 2.8. The full lesson can be found in the description box below. Okay. Again, example 2, solve for x. X squared is equal to 4x. What do we do first? Can I divide by x? No. Why? You're going to lose a solution. So the first thing is we need to get it in standard form. So if you that kind of go like writing notes, the first thing is to get the equation in standard form. That's number one. Ayat, you don't like writing? You don't, right? I'm the same like you, huh? So I'm going to do maths, the numbers. Right, so you take 4 over. So, what is standard form? In the form of ax squared plus bx plus. Okay, that's standard form. So you take the 4 over, it becomes x squared minus 4x is equal to 0. Now what do? Common factor. It's a common factor of x. So you take the common factor out. What am I left with? X minus 4 is equal to 0. Now we have two factors, so we're going to go into the factor theorem rule then. Which we set each factor equal to 0. So x is equal to 0, which is that one, or x minus 4 is equal to 0. So x is equal to? Any issues here, people? You're all okay with that, no? Coffee? Right. Let's get on with our lives. Example 3, and example 3 is on page 33. So in example 3 on page 33, again we are asked to solve for x. For x squared, 2x squared plus x minus 6 equal to 0. So, is that in standard form of ax squared plus bx plus c? Yes. So what do we need at this point? We need to factorize. So what goes on the line? 1 and 2 on the side. 1 and 6, 2 and 3. Do we add or subtract the products? Subtract. Why? The last term is negative. 1 times 6 is 6, 1 times 2 is 2. 6 minus 2? 4. What are we looking for? 1. 1 times 3 is 3. 1 times 2 times 4 is 4. 4 minus 3 is? And that's what I want. Now what if that didn't work? What would I have done then? I'd have swapped one of the set of factors, normally the one that has the least, if it doesn't work, okay? But if the coefficient of x is 1, or the constant term, or the last term is 1, then normally if you swap those factors around, 1 and 1 remains 1 and 1. However, if there are numbers other than 1 as the coefficient of the first term and the constant term, then at times it will swap around. In this case, it didn't have to. Okay. So we said that in the bracket will go a 1 and a 2, and a 2 and a 3. Right? There's an x square here. So what variables go in the bracket? X and x. What about our signs? 1 plus, 1 minus. Why? Because that's negative, no? Plus and a minus. So the bigger one is going to be positive. It takes the sign of the middle term. Okay. So 1 plus 1 minus, the bigger one must be plus. So that's going to give us 4x. And that's going to give us 3x. So which one is greater? The 4. So that's going to be minus. That's going to be a plus and minus. Okay, you understand, people? Let's go. So we say x plus 2 is equal to 0, or 2x minus 3 is equal to 0. Set each factor equal to 0. Bring that 2 over, becomes x is equal to negative 2. 2x is equal to 3 divided by 2. X equal to 3 over 2. Any confusion there? No? Any questions? Yes, Michael? Yes? A common factor, what would you have taken out here? 2. Alright, let's see. So it's x squared carrier. Plus 1 over 2. X minus 3. But now if we're going to apply this trinomial factorization, we never work with fractions. You understand? So can we factorize if it's not a common factor? No. We wouldn't want to work with fractions then. Okay, all our rules in this case was applicable to integer values basically. Okay. Is there another example? Yes, okay. Let's get it quickly. Example 4. Example 4 is on page 33. So what do we have to do first here? Example 4 on page 33. What do we do first? Can we say that x minus 1 is equal to 10 and x plus 2 equals 10? No. So what do? Get rid of the brackets, multiply out. Not so? So x times x is x squared. What's x times 2? 2x. Negative 1 times x, negative x. So I can say plus 2x minus x, or I would have just replaced it with x. Negative 1 times 2 is negative 2. Minus 10 equals 0. Why did I bring it over? Because I want to get it in standard form. So that's going to give us x squared. What is 2x minus x will be plus x minus 12 is equal to 0. Now what do? Am I moving too fast? No, okay. So what goes on the line? On the product line? 1 and 1. 1 and 12. 2 and 3 and 4. You add or subtract? Subtract because there's negative. So 12 minus 1 is 11. What am I looking for? 1. That's 6 and 2. 6 minus 2? 4. 4 minus 3? 1. And that's what I want. 1 and a 3 or 1 and a 4. So in the brackets goes a 1 and a 3, a 1 and a 4. Okay? So there goes x and an x. Not so. Worry about this now. Okay. So what about our signs? 1 plus 1 minus. The bigger product must be positive. So the 4 is going to be bigger than the 3x. Not so? So what do I say from here? X plus x minus 3. X minus 3 is equal to 0. Or x plus 4 is equal to 0. So x is equal to, I know this is ugly on the side, but x equal to 3 or x equal to negative 4. Okay, any issues here? You all understand? Who doesn't understand? We did this last year already, no? Example 5. And there's the last example here, correct? And page 34. Example 5 on page 34. Okay. It says solve for x. We got 2x into x minus 1 plus 3 equals x minus 2 times x minus 4. What do we have to do first? Huh? Get rid of the brackets. I'm going to pause the video at this point and give you a chance to do it quickly while I sort out the board, okay? Okay, so the steps that we need to go through again. Firstly, multiply out, get rid of the brackets. Secondly, standard form. Thirdly, factorize. And then fourthly, set each factor equal to 0. So let's go with that quickly. If you multiply this out, what do we get? 2x squared minus 2x plus 3 equals x squared minus 4x minus 2x plus 8. All agree with that? Okay. Bring everything to one side because I wanted to get in standard form. So it's 2x squared minus 2x plus 3 minus x squared plus 4x plus 2x minus 8 is equal to 0. I could have added like terms there if I like, whatever I want. Okay? So 2x squared minus x squared is x squared. Negative 2x plus 2x cancel. Then I'm left with plus 4x. 3 minus 8 is negative. 5 is equal to 0. You all agree with that? So it's now in standard form. Now we need to factorize. That's for some two factors there. We've got x and x, 5 and 1. Plus and minus. All agree with that? So what do we do now? We set each factor equal to 0. So x plus 5 is equal to 0, or x minus 1 is equal to 0. So x is equal to negative 5, or x equals to 1. And you can test it by plugging 5 into the original equation on either side to see if the equation is balanced. Okay. So this lesson is going to be very important with this exercise, which is exercise 2.8. The odd numbers I want you guys to do for homework for Monday's lesson. Okay. Stop the video at this point. I'll check your books so by the start the side. So you must go straight into exercise 2.8 now.